This is the first ever image of a black hole, released by the Event Horizon Telescope collaboration on April 10th, 2019. It shows plasma orbiting the supermassive black hole at the center of the galaxy M87. The bright region shows where plasma is coming towards us, and since it's traveling near the speed of light, it appears brighter when coming towards us and dimmer when going away. This is called relativistic beaming. From the images, scientists can tell that the plasma is orbiting clockwise. It takes around 2 days for the plasma to complete one orbit. Here, we are looking at the black hole using electromagnetic waves with a wavelength of 1.3 millimeters, radio waves. This was the part of the spectrum used to make the image because it can show us the features close in to the event horizon, and it can pass through the accretion disk and interstellar dust to reach our telescopes. The supermassive black hole in M87 is very active, meaning it's constantly feeding on lots of matter from its glowing hot accretion disk. But it also has narrow collimated jets above and below it, here shown in blue, thought to be created by incredibly strong magnetic fields. The jets extend out at least 5,000 light years, and one of them appears to be pointing almost straight at us. Relativistic beaming is again the reason we can see the jet coming towards us in this Hubble Space Telescope image, but not the one going away. Since the jet is pointed almost straight at us, I'm thinking our perspective is almost perpendicular to the accretion disk. But let's have a look at what we would see if we were looking at different orientations. The warping of space-time around the black hole means we can see light even from parts of the accretion disk behind the black hole. They are lensed above and below the shadow region. Not gonna lie, this is so trippy I could stare at it for a long time. So the big question most people are going to be asking is, why is the image so fuzzy? The answer is, because it's so tiny. Don't get me wrong, the black hole itself is huge, supermassive in fact. As measured from this picture, the black hole has a mass 6.5 billion times that of our sun. The actual size of its shadow is nearly the size of our solar system. But located 53.5 million light years away, its size from our perspective is only about 40 micro arcseconds. That's the angle it makes on the sky. To understand what that means, take the whole sky and divide it into 180 degrees. Then divide a degree into 60 arc minutes, and an arc minute into 60 arc seconds. Divide an arc second into 100, and into 100 again, and into 100 once more, and that is the size of the black hole shadow, only about 40 micro arc seconds. It puts us at the very limit of what we are technologically capable of seeing. In fact, to get this sort of resolution, due to the basic law of physics, the diffraction limit, we needed a telescope the size of the Earth. That being impractical, the scientists used 8 telescopes spread across the globe. They all simultaneously observed M87, and as the Earth rotated, that helped fill in the Earth-sized telescope that they were trying to simulate. But M87 was not the only black hole they looked at. They also observed the supermassive black hole at the center of our Milky Way galaxy, Sagittarius A star. It's much closer at around 26,000 light years away, but also much smaller, with a mass only 4 million times that of our Sun. It's also less active, only periodically gobbling up matter, and it would have much more variation over time, with matter orbiting every 4 to 30 minutes. Perhaps for these reasons, the image of Sagittarius A star isn't as good. But it still shows the same black hole features, confirming beyond a shadow of a doubt that black holes do exist. The general theory of relativity, published over 100 years ago, is supported again, in spectacular fashion, in the strongest gravities and at the limits of our ability to test the theory. What I love about moments like this is the ridiculous extreme things these scientists did, these 200 scientists, in pursuit of a goal that seemed impossible, and yet they achieved it. I want to extend my personal congratulations to everyone on the team for an amazing discovery. I'll be linking to all their work in the description.